the day. Monday, theme of the day, movie character day. Movie character day. Again, 7 o'clock coronation in the auditorium. Burning of the F immediately following the coronation. Next week also, Young Life All-Nighter, Mall of America Valley Fair. If you want information on that, stop in the office to apply. Those are also in the computer. Forum Friday today, Mr. Whitenberg's room.
Hey.
Trump's re-inauguration controversy.
Why are you over here? Get away.
Topic to be discussed. Call please stand for the pledge. To the flag.
Of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All on this day, Mr. Tracy.
Remember, these might be functions that you're not as familiar with because we haven't explicitly reviewed them. Doesn't matter what the function looks like. We talked about how to find end behavior yesterday. That's all this is asking for. Can you determine what the end behavior is? How did we find end behavior, even of something that I'm not familiar with? Who's still going? Almost there? Okay. Good. Okay. So the first one, boy, has it been a long time since we saw rational functions, and we didn't see them this ugly either. Or at least we didn't have to graph them yet. But if I go to this graph, we're going to see, what's that, plus or minus a third for vertical asymptotes, plus 7, 1/3, 1/3, 1/6, 1/7, negative 1/6, 7, 12, 21, 12, 1/6, 36, and 5, 22, 36 is 11/18. Have zeros at negative 1/6 plus or minus square root of 22 over 6. So like, and like itty bitty right there. And then you'll have a y-intercept at 7 and a horizontal asymptote at 4. Okay. Seeing if I remember stuff. Well, that doesn't make sense because then we got, oh no, does it cross through? I was just like, here's numbers, threw them on there. Does it cross through the horizontal asymptote? Is it a big one like this? Oh.
That's why I said, oh my gosh.
But those are my x-intercepts. Oh, they're on the outsides because I can't count. Okay, never mind. So like, meh. A butt up. A sixth plus roughly 5/6 is more than a third because I'm tired. Oops. Okay. You get a graph that kind of looks like this. The moral of the story is I take this and I jam it in my calculator and you spam 9s, right? So if I want to know what the limit is, I spam 9s, positive and negative. And in both cases, the limit of my function as x approaches, you can get lazy because I said this is okay if they go in the same spot, both plus and minus infinity is just 4. If you wrote them separately, cool. If you wrote them together like this because they went to the same place, cool. All right. The other one, maybe that one's a little more familiar because, you know, algebra 1 and 2. That one, member transformations, horizontal translation, right 3, vertical translation, up 1, vertical stretch by factor of 1, square root means perfect square steps, but on its side. So it's going to start right here and then up 2 over 1, up 4 over 4, and it's going to head off into the wild blue yonder like that. Okay? So if that's what the graph looks like, I want to see who was paying attention to our discussion yesterday. We know that the limit of g of x as x goes all the way to infinity is infinity. But how do I write the left end behavior? Okay. There were two philosophies. I said that this book, unfortunately, would say as it approaches negative infinity, the limit does not exist. said what we will do in here, because it's what I've always done and it aligns with what you will do in calculus with Mr. Spear, is the limit of g of x, like Lars said, as x approaches 3, but I say 3 from the right, okay, is 1. So if you had either of those, I will take it. They are both equally correct. It's just that our book likes to use the one on the left. Me and Mr. Spear like to use the one on the right. Okay, I will take both. Now, you didn't have to have the actual graphs on there. That was just to show you what they look like. And because Frank is atrociously slow on the calculator and I didn't want to use it. We're going to say, did you have correct limit notation? Did you just have limit function x approaches thing equals number? Did you have limit notation? Did you go to the correct plus or minus infinity and 4? So did you have those two things correct? Correct notation, correct values. If you had them separate, also cool. If you had them combined like this with plus or minus infinity, also cool. Did you have the correct thing and either of these the correct thing in there? And then what was the other one? Brain fart. Come on. Where'd it go? Well, that's like a thing. Did you have the right things? Did you have the right things? Did you have the right things? Were they all limit notation? I fat fingered a +3 instead of a -3. The little goof. I wrote this, but I didn't say 3 from the right. I didn't have the little plus on there. So the one floater for the little thing. Okay? Anything else? Good talk. I did not pull up the book yet because no one asked a single question. Do we have questions? Anything from 1-3? Back half of it? Maybe something from the first half that's still a little fuzzy. Okay. You made it through 1-3. That had the continuity test in it. Just like you made it through 1-2, you no longer have to do the symmetry test. You made it through 1-3, you no longer have to do the continuity test moving forward. Now it's just expected that you can do that if you need to prove a limit. Except for when we do the quiz next week, then you're actually going to have to do that because that's one of the questions. Okay. But moving forward, section 1-4 on to forever, when it asks for end behavior, when it asks for continuity, you can just say it. All right? So we talked about intervals increase and decrease. We got that far yesterday. I know we went through 1B. We started talking about extrema, what makes a relative versus a absolute maximum or minimum. When I write intervals of increase and decrease, I always use what? Never use brackets, always use parentheses, because I am neither increasing nor decreasing at a point. Like literally, it is called an interval of increase and decrease. Acceleration or deceleration depends on change in time. I can't be speeding up or slowing down at a specific moment in time. So I never use brackets when I do these. Point of inflection. Someone tell me, remember, maybe, possibly, could be, chance of. What is a point of inflection? Okay, it's the change in the rate. So it's still decreasing at that point, but it's not, it didn't go to increase then decrease. It didn't stay constant for a point. It just changed the rate. Remember? I'm slowing down. There's a vehicle in the median. Oh no, I think it's all right. I'm going to let off the brake. Oh crap, yeah, that is caught. And then I slow down more. Okay, the rate that I decelerated changed. Okay. So then we did not get here, right? Okay, cool. Everyone got their calculator on hand. Estimate and classify. How about that? We ain't going to estimate because we're just going to do it for real, which is actually going to get rid of multiple examples here. What? Are they doing that again? No, just go find the Extrema. Y'all been through Algebra 2. Okay, we don't need to support numerically with a table because we're never going to do that. We don't need to estimate because we can find it for real. Can anyone tell me how I find Extrema for real? How do I actually find the Extrema? Okay, now there was the intermediate value theorem allowed me to change, allowed me to look for a zero in between negatives and positives. I can do a similar thing with the table. This is where the estimation comes in, is I would see my table is increasing, 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 and then decreasing. So maybe I'd make my table go by tenths. And then I would just look at the table and I would estimate when it stopped increasing and started decreasing. So I could use that to find it. You might have been heading down the right trail there. Okay, Paul says the zeros. Remember, you can calculate zeros. You can also calculate extrema. Do you remember where? Like, what if this was just a parabola? Do you remember finding a vertex? You calculate a maximum. You calculate a minimum. It's just you're going to have to do multiple of them because you're looking for a relative. So I plug that equation in. Y equals x to the third. Come on now. X to the third minus x to the squared minus uno. I said minus uno. There we go. Okay. Oh, it's minus x. Well. God, this thing is so atrociously slow. X. Okay, so I got a graph. I do second right above. Remember, everything above this top line here, the Y, window, zoom, trace, graph, if I do second that stuff, it finds stuff on the graph. Calculate is found in two spots. Stat calculate finds junk from my table, from my statistics. Second calculate, right above trace, says I will find stuff on my graph. I will calculate a maximum. I will wait for Frank. There we go. And to calculate a maximum, ask for a left boundary and a right boundary. We did this when we reviewed parabolas. Make sure that if it asks for a left boundary and you put it here, don't say, well, I'll just put the right on the other side and then it'll be cool. Because pay attention to where the arrows are pointing. What if I did this and I'm trying to find that maximum? I'm like, oh, oops. Well, I'll just put the other one over here, right? Because it's still on both sides. Look at where the arrows are pointing. I would like you to find the maximum in here. Right? If I tried to do that now, my calculator is going to say, you suck. Right boundary is less than left boundary. It specifically tells you what you goofed up. So make sure that it's always left and right boundary correct. Find your... You also don't have to manually move Blinky around. You can just poke a button like at 0 and say, go find a maximum somewhere in there. It'll ask you for a guess every time. I never care because it's going to tell me the answer anyway. There we go. Now, if you know a fraction, or if you recognize a terminating or repeating decimal, maybe you should tell me what that actually is. Okay, so we're going to classify this as a relative maximum at -1/3, point 185. That's a fraction. That's a repeating decimal. So if I don't know what that is off the top of my head, you can always come back here and say 185. Oh, come on, Frank. Just spam it a whole bunch of times and then go math, change that to a fraction, please. Or you could put 185 over 999 and simplify it. 5/27. Okay, so if you recognize that this is a rational number, please write it as rational answers. Calculate a minimum. This is so slow. Somewhere between 0 and 2. Like, y'all who were in here before, you remember it wasn't this bad. I swear it wasn't this bad. This is the new computers are trash. So, relative minimum at 1, -1. Be smarter than the calculator. We talked about before, why does it say 0.9999999 and then the little bit of round off? It's where we put Blinky, right? Some of you might have just straight up had 1, -1. It depends where you put Blinky because it takes those numbers and it puts them into an algorithm. So that happens. Just state whether it's relative or absolute. Go ahead and find it for real. We are not going to estimate. So let's come down here and find, let's do 2a. Plug it in. There are 3 extrema to this. Never say that there's a absolute minimum at -infinity. Remember, extrema are where it changes from increase to decrease or vice versa. So because it goes down to -infinity, don't say the absolute minimum is -infinity. Okay, because it never changes at infinity. So just find those 3. I'm going to trust you all to press the buttons the right way. Hopefully you all get the same thing, because I ain't going through that mess with Frank again. I'll use calculator if I have to on there, but boy, that's something. I suppose I can do attendance, huh? That kid's here, that kid's here, that kid's here. Mariah was here. Those ones are all here. Cool. Okay, just looking at these, I know that this is relative or absolute, maximum or minimum. Relative, minimum or maximum? Maximum. So I know that's a relative maximum. And then you give me approximately, because unless it's an integer value, you are cutting off part of the answer. Same here. Same here. I know this is a relative minimum. I'll say approximately here. This one, it is the highest that the graph ever goes, so I know that it's a absolute maximum. Okay. Now, let's see if y'all press the buttons and got the same thing. First one, relative maximum. About how much? I don't want to press buttons. Frank sucks. You tell me. The relative maximum, so negative 1 point, meh. I haven't said the decimal thing in here yet, have I? Okay. Regardless of what the instructions ever say in our book, we will always write our answers in simplified fractions, simplified radicals, terms of pi, I, and e. And if you have to give a decimal approximation, you will always go out 3 places to the thousandth. I don't care what the instructions say. If they say to the nearest inch, too bad, go 3 places. If they say to the nearest 0.5, I don't care, go 3 places. That comes from hard experience of working with kids who could not do the expressions. 3 places meant that they were still accurate in their calculations. Okay, so 3 places, please. Negative 1 point who? 5.2 mutter? Oh, okay. Next one. 2.06 mutter. Okay, relative minimum, we're at negative 0.305. Someone argue if you're not getting these. Okay, more, faster, faster, louder.
Negative 0.311.
Absolute maximum.
1.075. 3.039.
Does anyone dispute these numbers? Y'all remember how to press buttons? Cool. Then, this said estimate. I said no, just find them. This says, can you estimate? Yeah, just find them. So what does this say? Use the calculator to approximate the extrema. What did we just do? Yep. We know how to do that. Okay. We're not going to estimate. In fact, do that in the homework too. If it says estimate, just find them for real. All right. You all been through Algebra 2. You know how. We just had to review how to use a calculator. Okay. There we go. Use Extrema for optimization. Now, I know how to find Extrema. Y'all shown me that. But do you know how to make the equation in the first place? And then Satan said, let there be words with math. Suppose we got 75 orange trees in a grove. Each one is going to produce 400 oranges a year. Suppose every additional tree planted, the yield per tree goes down, but it's a whole nother tree. You've heard of the law of diminishing returns? The more I do this thing, at a certain point, it's not going to be worth it. Cramming for a test. The nervous grin on Anna's face. The more you cram for a test, at a certain point, you ain't doing any good. You're just freaking yourself out. Go to bed, get a good night's sleep, have some breakfast. Okay? Like, you will not do any more because of the law of diminishing returns. This is the same thing. Because those trees, they're all fighting in the same space for the same nutrients, the same resources. So at a certain point, the more trees I add, the yield per tree is dropping. At a certain point, the more trees I add, now they're just going to be too clustered in the space, and I'm actually going to be harming the grove. So how do I write that as a function? I'll start with the basic, see if you can fill in the blanks. The total yield is the number of trees times the yield per tree. What did they say it was originally? Okay. There were 75 trees times 400 oranges per tree. I now need to modify that based on I'm going to be adding an unknown number of trees. Well, yeah, this is yield per season, right? Like, okay, we're going to have to take that yield and turn it into 400 per tree, right? Yield times the number of trees. And it's going to go down to for every tree that I add. Do I know how many trees I'm adding yet? I take the yield per tree times the number of trees. Well, the number of trees is now 75 plus I'm adding an unknown number of trees. There you go. Make sense? Like, how many trees I got times how many they give me is my total number of oranges. The number of trees I get, I'm going to add to it. Every time I do, I make the yield go down. This is how you create the function. Now that I've created the function, how many additional trees, x, should be planted to achieve the greatest total yield? Y'all remember algebra 1 and 2. What is this function going to be? It's a quadratic, right? Because I have two x's in there, I'm going to multiply this out. Now, you can just type it exactly like this in your calculator. You don't actually have to distribute, but if you feel like it, that's negative 2x squared, negative 150x, 400, so plus 250x plus 475, 2 is 153,000? That's just 3,000? Right, 4 by 75 is 300. Two more zeros. 30,000. Okay. So I can plug either one of those into my calculator and it's going to give me the same parabola. This parabola has a negative out front in the A spot, so I know that it's going to do one of these. Analysis of functions. What is this point going to be? It is a y-intercept. What is it specifically going to be? When I add no additional trees, how many oranges will I get? 30,000, right? And from there, I'm going to add trees, and my yield is going to go up. At a certain point, I'm break even. Like at that point, if I add any more trees, I'm just going to make it worse. If I cram harder for the test, I'm just going to make it worse. I've been staring at these 6 problems for an hour. Staring at them for another 20 minutes is just going to make it worse. The law of diminishing returns. So, that means when I plug this in, I'm going to have to go find a maximum, and I'm going to need a window that actually fits. So, remember, I can type it as the original. I can just say 75 minus plus x times 400 minus 2x. I can type it as the original statement. I don't actually have to simplify it. My window, well, I know that I'm starting at 30,000 oranges, and it's going to go up from there. So I probably want my y's to go up to, what, 50,000? 80? I don't know. I want to try 50,000 and see what happens. And we'll go down to 0, right? Okay. So right now this has an x-axis of negative 10 to 10. Oh, that's not going to do me very good now, is it? Because I've said, look at my window, I took away 10 trees to I added 10 trees. This isn't a sufficient window. But I can change that to, I don't know how many trees we're adding here, so I'm just going to throw 100 in there and hope that we see it. Hey, I saw it, right? Maybe got back, but I see that vertex. So I'm going to say second, calculate my maximum somewhere between, I'm guessing, 2 and 99. Look at those arrows, right? It's in there. I don't care about the guess. Just tell me the answer, please. Frank. Add 62 and a half trees. Okay. Can I plant half a tree without being pedantic about it? Okay. So now we take what we know about parabolas. A vertex has what running right through it? So if this is 62 and a half trees, take a wild guess what happens at both 62 and 63. Same thing, symmetric, right? So I found what the maximum was, but you have to be smarter than the problem. You have to interpret it. What am I doing? What was the point of the problem? What question am I answering? How many trees should be planted to give the greatest total yield? So should I plant 62 or 63? Okay. At that point, you got to decide. Depends on the space that I have. So maybe I want less. Maybe I want that 63rd one because they just happen to be in perfect rows of 7 or something. And it just going to make you twitch if that one spot is empty. Maybe I do 62 because the real world, planting that extra tree is going to cost money. If it's the same yield, how about I spend less money? You have to qualify your answer. Okay? So I would say I'll plant 62 because less space, less money, probably. I'm going to say 62 additional trees, and it's going to give me a yield of, what was that, like 31.8 something? 30 what? 37,812 oranges. So I have to be able to alter my graph so that I can see the relevant features. I have to interpret that vertex in the context of the problem. And you have to know how to write the function in the first place. Dare I ask this particular crew if you remember geometry? Okay. So I'll just go through the next one instead of setting you loose on it. Glass candle holder in the shape of a right circular cylinder. Candle, cylinder. Right means that the height is perpendicular to the base. It's not a glass jar that's tilted. Okay? They make them. So, right means base perpendicular to length, or height in this case. Cylinder, circle at bottom all the way through top. Okay, don't say it. Has a total surface area of 10 pi square inches. Do I remember how to do surface area? Yeah, there's a rectangle and two circles there. Do you remember what the area of a circle is? Pi r squared. But read what came right before that and don't interpret it in any other context. It has a bottom and no top. So normally, surface area is 2 pi r squareds, two circles, plus pi r, 2 pi r. Y'all remember the thing like if I were to take this can and cut it along the edge and roll it out, it would be a rectangle? So I know that this is the height, but what's this? The circumference. That's where that 2 pi r comes from. 2 pi r times h. Okay? Hey, if I had no idea what the surface area of a cylinder was, what could I do? Google that stuff. Use your resources. And if you ever have a problem like this in like a quiz or a test in my room, I just give that formula to you. Okay? Determine the radius and the height of the candle holder that will maximize the volume. What's the volume? Think about it. I'm taking this circle and I'm stacking that circle this high. Pi r squared h. Okay? So those are the formulas normally. Now someone already said it. So that means no tops around here, only bottoms. Lazy. So, now what? Maximize the volume. All I got is what? Start plugging in what you know. What other information did they give us? The surface area is 10 pi. We had one like this during our review, or our Chapter 0 review unit, where we had to take, what was it, like the perimeter of something, rearrange it, and plug it into the area formula. We're going to have to do the same thing here. They said what radius and height will allow the maximum volume. So I have to have the volume equation at the end of this. But my volume equation right now has too many variables. I need 2 variables, not 3. Right? Output, input. So how can I get rid of one of the variables? How could I eliminate or substitute one of my variables?
Move it over. Use the substitution or elimination method.
Yeah, right? How about I take this, 10 pi is pi r squared plus 2 pi r h. If I divide everything by pi, 10 is r squared plus 2 r h. If I take 10 minus r squared is 2 r h, and then divide by 2r. I have h is thing with radius. Okay. You have to rearrange one formula to plug into the other one. And now I say the volume in terms of my radius is pi r squared times this whole honkin' thing, 10 minus r squared over 2r. Now I can simplify that, or I can plug it in just like that. So cancel, cancel. Distribute pi. 10 pi minus pi r cubed over 2. So you can either use the full green thing or the purple thing. It don't matter. You're going to dump it in your calculator, and it's going to be some goofy function that's going to have a maximum to it. So y is, I'll even plug in the original. Okay, clear. We're going to say, where'd pi go? Pi r squared, I have to use x, parenthesis, alpha y equals is a fraction, 10 minus x squared over 2x. Okay. Does everyone get the function at least input? I know that some of you didn't use these calculators last year. Okay. I had to replace h so that there's only one variable or type of variable on that side. Alpha y equals brings up a fraction. I got to use x instead of r because it's just my input, my independent variable. Okay, now we need an appropriate window so I can see the maximum. I'm going to press a button that may or may not work. In my experience, it's been a crapshoot whether it works, but sometimes it's worth just trying. You know how we did zoom stat to find my statistics specific window? I can also zoom Zoom fit is supposed to zoom in on the relevant features of the graph dependent on the type of function I input. So it's going to go look up in its memory, hey, you've got an x times an x squared. This is going to be a cubic with a rational. Okay, rational cubic. I look over here. I need to have x-intercept, y-intercept, maximum, minimum. I need to have this stuff. It'll zoom into where those things are, supposedly. Sometimes it just doesn't. Sometimes it zooms in somewhere really stupid.
Like it's still on like your.
No, I hit zoom fit. So it's changed the window to hopefully find all these features. Now, see where it zoomed. I'm pretty sure we don't need to go down to a volume of negative 100 or 1.5 million. So I said sometimes it works, sometimes it doesn't. But I did find that my maximum did occur before 100 on the x-axis. So I'm going to change, come on you, come on you. Maybe I'll say from -5, just so I can see the x-axis, up to 500? Oh, 100? Okay. Well, it did occur before 100. We got that. Okay. Come on, Frank. All right. So I'd come back to y equals. I put in pi r squared times this fraction. Now the parentheses shouldn't matter, but right? Yeah, that's what it was. That was original green. Yeah, pi r squared. Okay, so maybe I don't need to go out that far. Maybe it's just 10. In fact, I'm being a little facetious here with the 100. Come back to the original problem. Frank, let's go. Okay, come back to the original problem. What is the object we're talking about? The maximum volume and the radius and the height of a glass candle holder where x is going to be inches. Are you going to have a candle holder that has a radius of 100 inches? You can. If you really want to, you can have a candle that is a circle from here all the way back to that table in between Colby and Lars. Okay. Well, x is my input. My input is my radius. Do you want a radius of 100 inches on a candle? I mean, that's not a candle, that's a bonfire. So, being a little facetious here, I don't need to go out to 100. Calculate my maximum. This appears to be somewhere nicely between 0 and 4. Come on, Frank. It is not. It is supposed to have a radius of approximately 1.826 inches. Show me original function. That means that we're typing something.
No, type the right thing.
Oh, that's why. There wasn't a parenthesis after the x squared, so that means you took.
36 the same though.
No. Because when you use a fraction bar,
Okay.
it puts parentheses around the 10 minus x squared. Okay, so it's the parenthesis thing that we're fighting with. The entire numerator needs to be in parentheses.
Yeah, it is. 10.
Okay.
It is.
Scroll over.
I can't. This is
Oh God. Oh, okay.
No, you wanna?
No. Okay, we're good. So
I'm used to writing like this, and I always put
you
the number
need.
in parentheses.
Okay, your double parenthesis here.
Mhm.
This parenthesis says this is what I'll multiply. This parenthesis says I'm about to group things. This parenthesis says those are done.
Oh, so I need a parenthesis between that and that.
I think so.
Okay.
That should be it. This is the difference between a right view and not. What are you doing? Okay.
What's your window? It's being.
Yep.
It's really slow.
Okay. Yeah, that's all good.
Oh no, I changed it. Now it's normal.
Okay.
I changed it so it's the same as yours.
Okay. All right. So it's just a matter of how we're writing it. That's how we're typing it in. Personal. Well, that's what's in campus. Okay. So we found out. Oh, hey, I should not have erased that because it asks for the radius and the height that will maximize the volume. We found out that the radius graph. Okay, the last thing I had should have been, there we go. The radius is supposed to be approximately 1.81, what was it, 815 or 816? 826? Okay. Remember, we said that the height was 10 minus r squared over 2r, right? So now plug that into h, if I know what the radius is. And the volume was about 19 point-ish. Okay. I lost the train. So you come back here. Now, because I just found an x value, I can store. Oh, I'm not going to fight with storing with you guys right now. No. Instead, we'll just alpha y equals, bring up my fraction. I'll say 10 minus parenthesis 1.826 parenthesis squared over 2 by 1.826. Okay. No, this will give me the height because it's not being multiplied by the pi r squared. I'm plugging back in and finding my height. So the radius is 1.826. Don't let it fool you. This is 1.825. This is actually a different number. That means it's a candle whose radius is almost its height. It's a wide, fat candle. I just want a candle. Okay. It's not big. It's a little candle like this. Like it's that wide, about that tall. Just a little. Okay. You don't need a blowtorch.
Why not?
You don't need a flame cannon.
Why not?
Because those are. It was like 1.826 and 1.825 were the radius and height. Okay.
Because they're what? Why no big flamethrower?
Because the last time I used one, I got in trouble because my wife said it affected our insurance. No. So,
Where do you buy them?
Not a flamethrower.
y'all, rate of change is really easy. Average rate of change is basically what we start doing in calculus. Said this pre-calc gets ready for calculus. The slope. Y'all know that slope is rate of change, right? Literally, if I say it costs $20 a month for your membership and $50 to sign up for whatever you're doing. Okay? Whatever you are signing up for your membership. Okay? $20 is the rate, right? $20 per month, rate of change. As months change, rate goes up. I keep paying more. Okay? So we know that slope is rate of change. What happens when you have an entire curved graph and that slope keeps changing? Because the rate here is not the rate here. The rate here is completely different, right? So that rate of change is going to keep changing between any 2 points. So all I can do is find the average rate of change. Its slope. Average rate of change says, since I can't find the exact rate of change for every single point along this curve, instead I'm going to say from here to here, well, my y's changed this much and my x's changed that much, so that is my average rate of change, which is just the slope. Okay? Now, given what you've said about geometry, I'm assuming that we don't remember what a secant line is. Have never even heard those words. Do you remember doing circles with tangent lines and secant lines? Here's x, here's 4, here's 18. Find out what x is. Oh, Jesus. Okay. All right. Okay. Yep. Y'all need to do some review on geometry before you go take an ACT. So anyway, looks familiar, right? y2 minus y1, x2 minus x1. The only difference is I'm saying the function of x2, the function of x1. Average rate of change says, since I can't find all of the slopes along that curve, I'm just going to find the slope between these 2 points and say good enough. Okay? So when I want to find the average rate of change, and it says on this interval, are these x's or y's? They're the x's, the interval, my domain, right? We spent all this time doing interval notation with domain. So this is x sub 1, this is x sub 2. I need the function outputs that also go with them. So my average rate of change, you can also write it as delta. Delta means change. Okay, you ever seen that before? Little goofy triangle in science. Okay, the change or rate of change is going to be, well, I know x2 and x1, that's -1 minus -2, but plug them in. Stick in -1. -1 cubed is -1 times the -1 is also 1. Stick in -1. That's now -3. Yay. Go stick in a -2. Negative 2 cubed is negative 8 times a negative 1 is positive 8. Stick in negative 2. 6 plus times negative 2 is negative 3 times negative 2 is negative 6. There we go. All I'm doing is plugging them in to get my y's. I have x's, I'm plugging them in to find y's. And I get negative 4 over positive 1 is negative 4. The average rate of change, if I were to graph this thing that has, what's that, negative x. So this graph literally has a 0 at plus or minus square root of 3, negative cubic like this. They're saying from negative 2 to negative 1, what is the average rate of change between those two? The slope between these 2 points on this cubic is about negative 4. I can expect that will be my rate of change in this interval. But you're not going to be able to find it by just looking at the graph, looking at the equation. An equation of a polynomial doesn't have a slope. It'll have derivative. Go to calculus for that, which is the slope along any point, and it's an entire quadratic. If I want to know on this equation from 0 to 1, my change, my average rate of change, you plug those values in. X sub 1, X sub 2. Or sorry, X sub 2, X sub 1. I say it backwards. Plug them in. Stick a 1 in there. Negative 1 plus 3. Negative 1 plus 3. Stick a 0 in there. I get 0. You're hurting my head, Paul. The average rate of change is 2. If I look at this particular graph from here to here, because this line goes through that little lump, it's a secant line. I can't actually find the slopes of everything in between. So I find the average rate of change, which is just the friggin' slope. Okay? But you got to plug the values in to find them. That guy. So from negative 5 to negative 3 on this ugly polynomial, what is the average rate of change? Okay, like if you're finding what the fuel economy is of your vehicle, okay, you get an average number from 0 gallons, 0 miles, to 321 miles and 17 gallons. Like when you find your gas mileage, that's your average fuel economy. It's an average rate of change. Was your fuel economy actually 21.3 the whole time? No, because when you were cruising along down the interstate, you were doing pretty good, probably 28, 29, little car. While you were in town stomping on the gas to get around grandma, I guarantee you it wasn't 28 or 29. Okay? But you found an average fuel economy. That's what this is. I got this polynomial, and I need an average rate of change. Okay. This is what the polynomial looks like. It's a quartic. If y'all remember polynomials, even, positive, leading term, and behavior will be positive infinity, come down, do stuff, up to positive infinity. Because it's a quartic, it can have 4 possible real zeros. In this case, it'll have 1, 2, 3, 4 real zeros. Okay, quartic. They're asking, what is the rate of change from -5, so way back here, so somewhere on the roof, to -3, which is right about there. How do I find that? Well, option 1, because I have it on my screen anyway, how about I trace to -5? And then to -3 to find my values that way? Or, if I'm back in that ask mode in my table, Frank, come on. This is actually the perfect way to do these because you'll have the coordinates on there. From -5 to -3, what is the rate of change? Well, this is now x sub 1, x sub 2, y sub 1, y sub 2. Go find your slope between them. 15 minus 455 over -3 minus -5. So what's that, -440? Negative. Which should make sense if I go back to that graph. The slope of that graph from the roof to here, down to 20 over 1. Yeah. Okay. So rate of change is just slope, but you might have to do a little bit of work to find your y values. Apply it. No, this is algebra 1. It's a parabola. From here to here, what's the average speed? Those are your two x's. Plug them in, find your y's. Something is thrown straight up from a height of 4 feet at a rate of 30 feet per second from 1.25 to 1.75 seconds. What was its speed? Yeah, we live in Disney hell, so. In fact, they were watching the second Wreck-It Ralph this morning before I left. So when I see the little spinning wheel up there with Frank, I'm like, why are you mad at the lollipop? Because I live in Disney Hell. So. All right, this is H. Okay, all you gotta do is plug them in so you can get those values. So what's that, 5/4? 5/4 squared, 25, 16s cancel, negative 25, negative 25. Plus 150 quarters. So 50 quarters plus 16 quarters. 66 quarters. It's 33 halves. So that's 7 quarters. It's negative 49. That's a negative 49 plus 210 quarters. 60, 161 quarters. 16 quarters, 176 quarters is 44. Half, 88, 55, 50. I tried to mental mojo. I'm probably wrong. Not even Samsonite? Boo! That means it's just time to quit. What'd you have for these two? 5 and what? So negative 9 over a half. Okay. So blah, blah, blah. Plug in formula, find slope. Okay. Cool. We're just going to quit there. Yeah. The whole week was a train wreck, so. Yeah.
I was here the whole time and I was still doing that.
Okay. A few items. One. Whole family's been sick. I have not been able to grade anything all week long. I've been barely getting from day to day to day to day, from class to class. I still have stuff there that needs to be graded for third hour. So I'll get to it when I get to it. The likelihood that I do not get to it anytime soon is high because the other 3 human beings in my house all have RSV. So the likelihood that I get it over the weekend, I'm pretty sure right now the only reason I don't is because of lack of exposure because I'm at school all the time. So if I don't get your stuff graded, chill. It'll get graded eventually. It's not going to change your score whether I do it now or then. Okay? That also means there is a potential that you will have to deal with video lessons next week if I'm out. If I go down like the rest of the house. If y'all don't know, RSV, it's normally for like infants and toddlers. Like it runs around daycares and preschools and stuff, but the fact that my wife also caught it is bothersome. It has an incubation period of like 5 to 8 days. So, like, it can just pop out of nowhere when you think everyone's cool now, and it lasts forever. It takes like 2 weeks to run its full course. Midterms are coming up 2 weeks. On the 30th is midterm. And then there's a 3-day weekend for you guys. So, I mean, stuff will be in. I already got like all the quiz 1 stuff done. I just need to get the rest put in. So, 2, next week is a Wednesday is an advisory day. Instead of everyone going, oh, try to take this one seriously. We have a representative from NAMI coming. North American Mental Health Institute or something. NAMI is really good for advocates for mental health and suicide prevention. If you all know, September is suicide prevention. It has drastically increased in incidence across the country in the last year and a half. Just go and actually try to listen. Hopefully they do a good job instead of just reading off PowerPoints. It would be a good one to actually give a rip about. Okay? No? Friday next week, so the madness that is homecoming is next week. Friday is an early release. It's an early release Maroon Day, which means you can leave at 11:24 if you are not locked down on the Spartan time list. Okay? I think all of the homecoming stuff starts at 1. Okay? If that's your jam, go do it. If that's not your jam, I've got a 5-hour nerdathon in here, so you're welcome to join. Because there's no way in hell you can put me in that gym with that noise. So, there's our housekeeping items.